Good morning, good afternoon, good evening everybody. This is not me showboating, but just proving that I actually did go travelling. I'm currently in Egypt. Now this is the last video I'll do while I'm still here. We'll finish off flooding and hydrographs and rivers basically. And then hopefully by the time I get to Japan, which is the next country up for me, I can then find time. It'll be tricky, but I'll find time to do a bit more on coasts and tidy up some of that missing knowledge. Okay, so this one basically is about flooding and how we can reduce the risk of flooding and things we can do and things people do and companies do and governments do to stop flooding. Well, the first way of putting this and breaking it down or revising it is much like coasts, to break it down into hard and soft engineering. Hard engineering are man-made machines, devices, materials to try and prevent the effects of flooding, whereas soft engineering is a lot more to do with working with nature and doing more environmentally friendly things, working with the environment. So in terms of hard engineering, the first kind of two-in-one to remember are dams and reservoirs. Okay, so a dam acts like a barrier to the river, and effectively what it does is it controls the flow of the river. You can slow it down, you can speed it up in certain areas. Now this can manage flooding in certain areas. What I'm going to do for this revision session is to tell you what they are and then look at some pros and cons of each as we go through. Obviously dams are very effective, but they are very intrusive. So what I mean by that is they take a lot of work to build, they damage the environment when they're built in, and they're very expensive. However, you can get hydroelectric power from dams. You can also provide jobs, you can also control the river flow a lot easier and sometimes prevent flooding downstream. Now what goes with the reservoir what goes with the dam often is a reservoir, which is a kind of a store of water like a lake behind a dam, and this allows the control of the river, so you can basically lower it or raise it as per applicable. If you're in London walking on the Thames, you won't see a dam anywhere. These are normally done in the higher areas, the upper or middle course of the rivers. Very, very rarely is it done in the lower course. Now what you find in the lower course is embankments. Now embankments, like the embankment station at London, is big walls on either side of the river, like the sea walls really. And what these do, very simply, big wall, is they increase the river capacity. They reduce the risk of flooding because the water's got to rise higher and higher than it would have done had the normal banks been there. And this also means that land behind the embankments, paths, roads, big buildings like River Thames has Big Ben right there, London Eye right there, these things are protected. Positives, they work very well and they last a long time. The negatives are they do need constant reinforcement over the years, and they are very expensive as well. Like you're talking millions of pounds for a few meters. Then you could look at river straightening. This is where you stop a river from bending and make it go straight, the idea being that it would go faster and then get out of an area quicker. So the water's here, for example, and it goes straight through, it's not going to flood here. The big obvious negative of that is that if you remove the water from this area quicker than further down somewhere else, you're actually going to increase the risk of flooding in that other area. So a river straightening, channel straightening the channel of the river, reduces the risk of flooding in one area, but it can pass it on just down the road, basically passing the problem on. Or you could build flood relief channels. So this is basically areas that can flood and are safe to do so, and you kind of make sure that they have lots of permeable land that can absorb the water and easy to manage. Now they are all things you can do from hard engineering, things you can use, things you can make, things you can build. If you're looking at soft engineering, there's definitely three that I would remember, and it's only worth revising three really. Well, the first one is floodplain zoning. Basically that doesn't involve building anything new. That just involves not building land on areas that are prone to flooding. Basically, if you have a river here, then a council might say, well, let's not build anything just either side of the river, let's leave that, make it safe, make it green maybe, and then build land further away. to reduce the risk of flooding. Note, this is not to make flooding impossible, but it's reduce the risk, reduce the likelihood. So floodplain zoning is what it's called. It's when you decide which zones are safe and which aren't, and then you build or don't build accordingly. You can also have afforestation. Now, afforestation is where you plant trees, and as I looked at last time, if you plant trees, this land gets more permeable, therefore more water can be absorbed, therefore the risk of flooding is decreased, it is less. And that's really, quite key in terms of reducing flood risk. The other thing is warnings. So evacuation and warnings, if you have systems like televisions and stuff, these are man-made items, yes, but you're not actually intruding on the environment. If you give warnings out to people in enough time, then this can reduce the impacts of a flood because people can relocate from that area. Obvious negative of this is it doesn't always work, particularly in LIC countries which don't always have the most up-to-date warning systems. Also, if you get flash floods, there's not much notice, so there's no point in doing that. Floodplain zoning, by the way, a negative is that you lose money because you can't build things either side, or it might be too late. But yes, ultimately there's some positive and negatives of each of them there. The last thing I wanted to go through was storm hydrographs. Now, I haven't got a pen and paper with me. I can't even use the computer screen because I haven't got a computer either. But there's just some key terms for a hydrograph because you never know. A question might say finish the hydrograph or label the parts of a hydrograph. So you start here. The line is the discharge of a river. How much water is in the river at a certain point at a certain time. So with a flood, that amount increases and will eventually go back to normal. You have little bars in the corner of a hydrograph. They are the rainfall. Okay, not every flood is caused by rainfall, but certainly a lot are. So you have the rainfall down here. Now the peak rainfall is when the rainfall is at its peak. So normally the rain gets worse and then it gets back to normal again. The same as the discharge, really. So discharge goes up like a roller coaster. That's the rising limb. Okay, the limb being that like kind of loop, rising limb. When it gets to the very, very top, the peak discharge, this is the point where the river is most full, and then it will start to go down on the falling limb. Again, like a roller coaster, you rise and you fall. The lag time is the time, don't forget it's all about time, between peak rainfall and peak discharge. The time between the most amount of rain and the most amount of water in the river. Now, a flash flood, a flood that happens very, very quickly without much notice, with a lot of rain, these bars are going to be pretty big in the corner, and there won't be much time between the peak rainfall and peak discharge. Also, if you're in an urban area, it won't look that much different either. It'll be very, very small because of all the impermeable spaces. However, if you get a flood in a rural area, it happens over time, remember, say like for example green areas get filled with water, absorbs it 'cause it's permeable, they get saturated so it still floods. That's going to be a subdued flood, so really wide time there because the rain will be more constant rather than quick, and the flood will happen, but it'll be a less steep rising limb, less steep because it happened over a longer period of time. The steepness of the limb is the time, so the steeper the limb, the quicker the time of the flood. The more gradual, the slower. And that's basically rivers. If you look at, the only thing I was going to say about is look at your example. I don't know what you guys in year 10 who are watching this will study. It might be the same case study as Banbury. You guys watching this in year 11, Banbury's your case study. All you have to do is look at which of those strategies Banbury used, what went well and why, what didn't go well and why. Because your question will be about either what they did or more likely to evaluate it. So what are the pros and the cons with these different methods? A very good revision technique for this topic is to have all the strategies of soft engineering and all the strategies of hard engineering on their very own table flashcard. You put what they are, what they look like maybe, good and bad. What they are, what they look like, positives, negatives, that kind of thing. Then if you can revise them, and I told you about I think 6 or 7 different ones there, then that's enough. That's definitely enough. You're never going to need more than that. Any questions, as always, let me know. I still miss you every day, and I'll see you soon. Alright, take care, guys.